Hello, everybody. This is Sarah Collada with Architecture Talk Tongue. Today, my guest is Daniel Inocente. He is going to talk to us a little bit about his absolutely remarkable career path and also currently working with Blue Origin in the space of architecture, space architecture, and innovation. Incredibly interesting, Daniel. Thank you so much for joining me on this podcast.
My pleasure.
So you actually worked for quite big architecture practices. There was Gary, HKS, SOM, also NASA before Blue Origin. So tell us a little bit about your journey that brought you to where you're at today.
My first job was working at Gary Partners. So that was a fun experience because straight out of school, I got to work on some remarkable buildings like the Guggenheim or the Battersea development in London. And for me, that was just really intense because you go from, conceptualizing things in school in the studio, and then you just get thrown into a project and you're working on technical drawings, learning how to go from, especially from Frank Gehry's perspective, looking at how you go from conceptualizing something, making physical models, and then trying to characterize that and turn it into something that's constructible. Even then, we were using some pretty sophisticated technologies like Digital Project that was built on the back of CATIA. And so we learned a lot about software. We learned a lot about constructability, materials, geometry. It was all really exciting. So that kind of opened my eyes to what architecture could be, because even though that was very artistic, it pushed the boundaries of how you can imagine, making something possible. And that really got me intrigued with what technology could do for architecture, because it's through technology that we can achieve, greater ideas, greater visions. And that led me into wanting to understand the role of technology in architecture more. And eventually I ended up at NASA, where I got a, 1-year contract. I learned a little bit about what it took to design things like missions or how spacecraft were being conceptualized. And even after that, that kept with me. So I wanted to continue pursuing that somehow in my research. And I continued that when I started working for SOM. That initiated the Moon Village concept that we developed there. So that was something that really opened my eyes to how we can work together with interdisciplinary partners like the European Space Agency to bring new ideas about space architecture, and as architects, how we can integrate some of those visions together with experts in that field.
So interesting. So let me just dissect this story a little bit, because I picked up on some incredible sort of steps you've taken from working with Frank Gehry going into already quite an interesting opportunity, which was NASA. So how did you actually make that jump? What happened exactly there? I mean, being interested in technology doesn't always land you a job with NASA. So tell us a little bit more about that time in your life.
Yeah, no, that was a transition where I was really open-minded. I wanted to try new things, still very young. And I saw an opportunity to apply at JPL. And so I took that opportunity and I got a nice position there as a designer. And I was, like I said, exposed to a lot of things, which was really exciting. And that just stuck with me. So I wanted to continue pursuing that in some fashion. But I always wanted to be involved in the practice of architecture, working on actual buildings. And so that, for me, that was more of a way to really extend my expertise and my knowledge and the skill sets that I had. Because ultimately, we're responsible for the built environment. And so we want to bring the ideas and the inspiration from space exploration back to Earth. And that's something that I always kept with me. How can I bring this idea of space exploration and technology development that's being done for space to the practice of how we build our environments? And it's actually what we're doing now, even at Blue Origin. We're involved in building inhabited environments for outer space, just at a smaller scale, but still the promise of what this could turn into is something that has, limitless possibilities, because, the sky is limitless. There's no boundary. And so when you think about inhabiting space, I mean, you can imagine things like O'Neill colonies or, large settlements on off-world bodies. So that's something that really intrigues me. I want to continue to develop as I progress in my career.
This is so interesting. So tell me a little bit about that specifically and the projects that you're working on, because I'm imagining that it's probably harder, or maybe it's possible to work for private clients within that sector already. I mean, I know that there is quite a few big entrepreneurial names that are now racing to space, like Richard Branson, and of course Elon Musk, and I think Jeff Bezos, and a bunch of them are working on actually traveling there. And of course, there's a lot of talk about inhabiting other planets. But what is like, how does it actually look realistically? Like, how far are we? Can we achieve that, or is it all at the concept phase? And in terms of experimentation, do you guys create, build, and experiment within these projects?
Yeah, well, the goals are very, they're very long-term goals.
Yeah.
Thinking about creating a base on the moon, for example, or going to Mars. These are things that are decades out, hopefully sooner. The moon is not that far, but we're still developing spacecraft that are just partially habitable. There's limitations, and those limitations have a lot to do with, the gravitational force of Earth and how much mass you can get up into space and the size of the transportation vehicles. So companies like Blue Origin and SpaceX, they're developing those capabilities, but it's going to still take time until we can actually design, engineer, and build habitable structures that are, for many people. I mean, we're talking right now, small crews of 4 to 6 people for mission durations that are maybe a couple weeks. But the longer you extend the duration and the more things you have to bring with you, the harder it is to, design those spacecraft or habitats. And so right now we're working on small scale habitats, small scale spacecraft. I mean, that's what the industry is doing. NASA is also supporting some of those initiatives. And it spans across different scales, from pre-integrated habitats, very small structures, all the way to experimenting with 3D printed habitats that could be maybe for, larger groups. And so that's where right now the industry is going. A lot of the research, the groundwork is happening, but this is going to happen. It's inevitable. And so it's really, it's fun to be a part of it, but it's also very important that we bring architects and designers into the starting of this, because what we do best is we integrate a vision that is more for human activity, and the systems engineering parts, those, they verify and they bring all the different expertise that are required for the habitats to basically maintain human life. So this is something that is very important, to think about, and we're working on it. Of course, it's not going to happen in a couple of years. It's not like a building project. It's something that we need to, very thoughtfully and carefully develop.
Wow, it must be still really fascinating. So, do you guys do like models, like one-on-one scale models, where you can step into it and test it out?
Yeah, definitely. So that's a part of the design process. You have to build some mock-ups, some representation of what you're actually designing, and then that helps us get a sense of, how the spatial configurations are, how the different systems are coming together. I mean, just like in the building industry, you want to do some mock-ups to test performance, to test human occupancy, and then just verify that what you're putting on paper or in 3D is actually conforming to the requirements and your vision. So there's a lot of that going on. There's like a back and forth. SpaceX also does that, build architects do that around the world. I remember when I was working for Frank Gehry, we used to do that all the time, from small scale models to large scale models. So that's definitely a part of the process.
And how do you guys experiment with zero gravity in this one-on-one scale? Do you get a chance to create zero gravity and float around those spaces, or?
No, that's not something we can replicate on Earth very easily for people. So yeah, you have to do, I mean, you could do parabolic flights. Those are quite constraining, but there's nothing like microgravity. You have to do microgravity, you really have to take your entire system to space. But there's different ways there's some ways that astronauts can train. So there's like underwater training. There's different kinds of mission scenarios that people have to prepare for. There's a lot of physiological testing that happens. One thing that people miss is that microgravity has very direct effects on the human body, because, the human body did not evolve to be in microgravity. And so we have to take that into consideration. and people need spaces and equipment to do exercises so that they can maintain their health. And that also comes at a cost, because you have to bring those spaces and equipment with you if you want to extend the mission durations. So that's something that the architecture has to accommodate as a programmatic element, and it's very important.
Mm-hmm. Because I was trying to imagine the actual sort of existence in a space like this, and I'm guessing since you're floating in space, it's not normal, like arranged like a normal place on Earth, right? You probably would have different applicants all around you, and you kind of need to move to, you know, your kitchen and where the food is, so to speak, and then where the water flows and where you take a shower, and so everything is like in a three-dimensional space. And the way you design it is, I think, with a concept in mind that a person can fly in it to that space, right? I just imagine that it would be really interesting to be in a space like this. I mean, how fascinating what you're doing. So tell me a little bit about future plans and what's next, or some of the most interesting projects that you're working on.
Well, I can't talk about the project in too much detail, but I can at least bring up, some of the things that have been published widely, which is the orbital stations. So that's a big initiative coming also from NASA. NASA is supporting commercial space stations, and Blue Origin is a part of that. There's other competitors also developing those capabilities. But the whole vision is that, after the ISS, that we want commercial companies to basically lead the direction of commercial space stations, because you want them to be able to operate that, so that then NASA can invest in doing the science and doing other kinds of missions, and then going to the moon, for example, or going to Mars. And so space stations are going to also be a big driver for touristic purposes. For example, it could drive a completely different kind of economy, like hotels in space. That's something that's very near term. We're talking about being able to do manufacturing in space. There's companies also involved in developing those kinds of infrastructures, because we want to be able to do as much as we can in space, harness the resources of space. There's a lot of, for example, like minerals and energy out in space that you can make use of. And so we want to find ways to access that, so that it becomes easier for us to expand and continue to grow as a civilization. But there's some really interesting projects. Like, one of the things that the Artemis program is focused on is getting humans back to the moon. So the landers that are needed for that are being developed. There's also new technologies, for example, like nuclear power, that's going to be developed to be able to provide sufficient energy for systems on the moon. There's also international initiatives that are talking about space-based solar power. Imagine building large solar arrays in space and then beaming that power back to Earth or to other locations. And then, of course, habitats are a big part of that. And ultimately, we need transportation. So large, heavy lift vehicles that can take people, large amounts of mass and many people, from Earth to the moon, to Mars, to many destinations. Starship is doing that. And I'm very excited to see the launch. Hopefully it happens. They're targeting next month. So let's see if that works. But there's a lot of great technology being developed right now, and Blue Origin is also a big part of that.
Sounds amazing. So I wanted to kind of pick your brains a little bit about how does one get into this. I know that a large part of my audience are people that are looking to reinvent their career paths, and also potentially expand to really interesting markets as they run their own businesses. So you told me how you managed to get to NASA, but I'm guessing now, looking back at your experience, you know much more about this, the technology, the knowledge, and what it takes for an architect to journey into this type of projects and also clients to work with. So would you give us a little bit of a roadmap, so to speak?
Well, I hesitate to define a clear roadmap for this, because even for me, it was kind of, undetermined. I took a lot of different paths. I was very open-minded to the possibility of working in space. And when I did make the decision, it was still, like kind of an existential decision, because I had always thought of myself as a design architect, someone who works in the building industry. But I think if you want to be a part of what's happening in space, it's important that you dedicate yourself to understanding first why space architecture or space exploration is important, why it's so insightful for society, and maybe even look at the history of what technologies have made their way from space exploration, space investments back to Earth, because we benefit a lot from that. And the discoveries that are made in those efforts, they pay back dividends all the time. Like this is something that is really understated. And so the more we challenge ourselves to, make habitation systems, transportation systems, and all these other capabilities, the more we're going to be able to bring those technologies back to Earth to help create a more sustainable and more, beneficial society. So for me, it was important to study a wide range of topics, to not just, focus on architecture, because a lot of architects, they tend to focus on, just basically building design. Sometimes it's a little bit too technical, focused on a particular part of the building process. But to think of architecture as an interdisciplinary, like field, and to bring different ideas from different backgrounds into that field. So working with engineers in the space sector, for example, for me, that was very important. Understanding how to work with engineers in that field was also very important, and coming up with viable ideas that an engineer in the space sector could actually see being possible. And so you want to be able to take your skills from the architecture world and try to implement those skills in the space field with research, with collaborations, with partnerships, and maybe tap into some potential contract working with an aerospace company. But those kinds of experiences really helped me. So when I was working at SOM, I was integral to building that collaboration with the European Space Agency, for example. That was for me, a very important project, because I got to learn a lot about the space sector. And then I built another one with Lockheed Martin, which was another very important project. And then with academia, with collaborations with MIT, with the University of Manchester. And I kept looking for that. I kept searching for people who were like-minded, who wanted to, bring these different disciplines together and explore what the possibilities are. And that led me to, working at Blue Origin. And now I find myself trying to, continue that path. Only the projects actually are becoming realized. Yeah.
Mm-hmm. Absolutely. Actually, I looked on your website, and you just mentioned SOM and your experience working with them. You wrote a really interesting article about tall buildings and the paradigm of a skyscraper. Did you actually work on Burj Khalifa?
No, not the Burj Khalifa. I worked on various skyscrapers. Burj Khalifa came before me, before I joined SOM. But because SOM, they're known for tall buildings, we got to work, especially in the New York office. I got to work on a number of tall buildings. It was a building in Guiyang was my first project that I got put into. And one of the special skills that I picked up along the way, like, going back to when I was working at Gary's and Gary Technologies, was learning how to use computational design software in the process. And so I applied that in the design of skyscrapers. And that helped me, communicate with the teams, build design ideas rapidly, iterate through different concepts, and then also bring in different systems like curtain wall systems, panelization, floor, like optimization of building design forms and core layouts and things like that. So there was a lot of very unique things that I picked up from learning digital tools that I applied to the design of tall buildings, but also other types of buildings like airports and museums. And that for me was, a very fun part of the design process.
Mm-hmm. I just posted a link here to articles written by Daniel, and also Daniel's website. If you guys want to check it out, he's got an extensive description of his career path, but also some really interesting articles, projects, and research shared. Super interesting. We obviously are in a very interesting point in with age of information, with technology being really at the forefront of architecture, I would say, more and more so now, inviting big architecture practices to the disrupt stage as well. We cover topics of technology because it is so crucial with the design of buildings and delivering the best solutions. And it becomes almost like this unique value proposition for a lot of offices to advance technologically, writing their own codes, writing their own softwares and things like that. And I think that all of this actually accumulates really well with what you're doing, space architecture. So I'm guessing that a lot of the softwares and the experiences that you've gotten with SOM and Gary and other bureaus, architecture bureaus you worked with actually apply really well. Do you guys still work on the same softwares now, or do you integrate, let's just say, the 3D design software that we use as architects with other softwares?
I still use the same software, but there's other softwares that I'm also becoming aware of or becoming more familiar with. But generally, like the principles of design, using systems engineering software versus architectural design software are unique. And the commonalities are really in the way that you think about it. For example, in the architecture field, if you use a particular software like Rhinoceros, you're just designing things. You're trying to visualize ideas about space and adjacencies and materiality. Of course, you're thinking about other constraints simultaneously, but you don't typically do it fully parametric. I would say, not everybody is really a parametric designer, much less a computational designer. But if you bring that approach to your design process from the very beginning, you bring in other variables, other layers of thinking that wouldn't actually expose you to possible solutions. And so computational design allows you to iterate very rapidly through many more solutions than you would if you were just designing explicitly. And that's something that I used in my process all the time, where I would develop a design idea, build a script for it, use computational thinking, and then look at the possibilities in relationship to things like structure, materials, geometry, form, adjacencies. And then you can start to really optimize, what it is that your vision started off from. And then in the space field, of course, there's a lot of systems engineering. So the tools that are being used are more like product life management tools, where you have different layers of products and parts, and then people are responsible for different parts because those parts belong to a different discipline. And then they put that all into one single model, and everybody can see what the other person is developing. So it's like live collaboration. It's much more like BIM, I would say, but actually from the very beginning. But I also try to introduce some of those, like computational sketch models into my process even now. And that's important. You want to keep flexible ideas being developed, even if they're disconnected at first, but always find a way to bring them together, because you need collaboration no matter what. And technology is becoming much better at doing that. Big software companies are actually now using the cloud, which allows us to share information very rapidly in real time. And you want to have that capability so that communication is constant and there's no like overlap, or there's no miscommunication, because if somebody does something and you forget to integrate that, then you have conflict down the line, and that could cause inefficiencies, or even worse, it could cause completely change in the design. So yeah, there's a lot of cool tools that I'm using now that I haven't used before, but I'm also very flexible with using tools. So I'm happy to learn new software applications.
Excellent. Would you recommend us some books or interesting documentaries, perhaps, on the topic of space architecture?
Sure. I just watched The High Frontier by Gerard O'Neill. So it's a documentary on Gerard O'Neill, and it's a really interesting documentary, but it talks about the visions that they had after the Apollo mission. So he was a scientist. He worked on particle accelerators, and then he somehow got into the world of developing these large ideas for architecture. That's what I would say, because what he was really interested, especially in the later phases of his career, was what the impact of space exploration had on human activity. And the documentary really characterizes his legacy and the way that he thought about that, and how he brought a lot of people together to think about space exploration at a massive scale. So that's a really great documentary. You can also watch some of the Netflix specials like Mars. That I'm really a big fan of that one. Or documentaries on like SpaceX. Those are really incredible. But yeah, there's tons of documentaries out there. And for books, I mean, if you really wanted to get down into building science, some of the books that I collected were publications by a company called New Technic. I really enjoy those books. They help you think systemically through the design process. It's like a design engineering company where they're really helping architects think about how to improve their buildings and optimize their buildings. But the books are really good at detailing the process. Yeah, there's a lot of other. I would say also, like, science fiction books are really good if you want to get into space. So I mean, Jules
Have
Verne.
the imagination going.
Yeah, exactly. Yeah, like Jules Verne. He's a great author. I have all of his books, so if you want to, pick up some of his books, you should definitely get inspired by him. And yeah, I keep an open mind to reading about space. Robert Zubrin is another good author. So he wrote a couple books. For example, like The Case for Space is a great book. I read that twice already, and it talks about, like, not just the purpose of going to space, but the economics of going to space, the different ways that we can achieve going to, for example, the moon or Mars, and very practical ideas too. Nothing too far-fetched, and things that could be implemented and are actually being implemented. So, yeah.
Which also I think could be very helpful for architects, because we always have to take into consideration everything: environment, economics, culture, people, practicality, functionality, materials. And I think that designing for a space that is yet uninhabitable, it's very hard to put it into context. So it's great to have references and, this research or books written to perhaps help with that context somehow.
Yeah.
Thank you so much. I really, really enjoyed it. Thank you for joining, me on this podcast and sharing such an interesting, story and about you as an architect, about your interests and passions, and as well as, the actual active work you're doing right now with Blue Origin. It's excellent. I did already share your link. It's DanielInocente.com, guys, if you want to check out what Daniel's doing. I invite you. There are really interesting articles published there as well. And yeah, thank you so much, Daniel.
Yeah, thank you, Sarah. It was nice talking to you.
It's a pleasure. Thank you. Take care. Take care, everyone.